Hey YouTube, so I just thought I'd show you, I'm going to try and recover this battery pack. Now this one, I've opened it up already and just had a look, and I'm probably not going to get much more useful life out of it, but this thing's been faulty for ages, and when it started having reduced life, really I should have started looking at doing this then, instead of leaving it in the box for years. This is a 14.4 volt battery pack. I think it's a Makita, but it's used in a specialist tool which is very expensive to replace. So I'd like to see if I can recover this and just get the tool back in operation. So basically you need to open her up. This I think was a cheap replacement already, so not an official battery. And the proper one's probably got a screw fixing, so you can get into them a bit easier. Anyway, I leave it at that, and that pulls off, and you get access to the cells. So this is a nickel metal hydride. It will focus. Nickel metal hydride and 3 amp hour, 3000 milliamp hour. So basically, I had to give it a bit of a whack. I was hoping it was going to pop out easy the second time, but not. So obviously we need to be careful wedging a screwdriver down in there. But all you need to do is get it out. So you've got these terminals on here. You've got your, I'll just show you on a meter, just a basic meter on volt test. That's the pack voltage across there, and then across these two terminals that would be your that's exactly the same. It looks like 4 terminals, but they're exactly the same, it's just that. And across there is a temperature sensor, so if the battery goes over temperature, it lets the tool know and shuts it down. But basically we've got massively reduced life on this thing, and it was still running, so it's not like the modern packs that can brick themselves. The modern Makitas can actually, the electronics brick them, but this is an old pack, and being a aftermarket one as well, it's also not got, probably newer packs don't have the same sort of protection. Be careful not to short across them. They do wedge these in there. Right, there we go. So that's pulled off of there. So as you can see, these are 1.2 volts, 12 in series, giving us the 14.4 volts nominal. So what we need to do is just go over them. Like I said, I have looked at the pack already, so I do know what it is, but just start on one of the terminals. So we can see here, here we got a positive terminal, I would guess. That's not a positive, and just work through. So we've got 1.2 volts there. Okay, probably don't even need to know what it should be. Well, you will do in a minute, but it says on the battery 1.2. What you need to do is go through, make sure they're all around there. Now, they're not going to be exact, but just work through the pack. And like I said, I found it, but so when we get to this one, see that? Nothing. Same as just shorten across the case. 0 volts. Okay, so we know that's our problem. Now what we can do, obviously, now these are in series, and the other connection is just simply this, it's just the thermistor now to monitor the temperature of the pack. And some nice thermal gunk. So what we need to do is try and recover that one cell. All the rest of them were at 1.2, so you might get more than one, but this is what I'll do. So just confirm, obviously that's showing 0 volts, so you can't tell which side's pos and neg. You kind of can if you know the cells, but measure the one next to it, and then obviously that will be, so if that's positive, that's negative, the negative will join the positives, you know, it's positive, and that's negative. So let's spin that to there. I'll just pop it in this battery holder. This is a little awkward to get in there, but once you're in there, this holder's really good. Make sure you've got a good connection on there. And what I've done, this holder, if you watched my other video, has 2 sense cables, so you can monitor on your voltmeter, and 2 power cables, so we can plug it into there. Now, okay, what I've done is left the power supply on. This is already on. Probably the wrong settings. That's where you can see this going up. And that's what we need to do. We need to gradually get this voltage up. And these are 1.2 volt cells. Now what you can do, just Google it. Just Google the chemistry you've got, say nickel metal hydride. You're probably going to charge them to about 1.4. So if we do that, we set this. Any power supply will work. This is a great budget power supply. This DPS 5015. You can use a cheaper version. They do a few versions with less power. You don't need anywhere near that power for this thing. So we'll set it to 1.4, and then we'll set the current, and really what we want to do probably is leave it probably leave it overnight, just at a really low current. So I'm going to try 100 milliamps, and there we go. What you'll see is this will just gradually come on up, the voltage will come on up, and hopefully we'll get it back to 1.2, and it'll match the other cells. If you do recover it, hopefully it will carry on working for a bit. Like I say, you need to do it when the pack is showing weakness rather than completely failed, so I'm not holding out much hope for this one. If you need it quicker, you can give it a go up in the current, and if you up the current limit, you'll see the voltage will rise much quicker. Okay, so at 300 milliamps, that thing's approaching the charge voltage, which is not a good sign. And if you probably wouldn't advise this on other cells, but you can whack it right up if you want and just try and force some current through it. And the cell, obviously you risk it, the higher currents you risk the cell getting hot, even venting or exploding. So you're best off Googling the chemistry and seeing what they say. Generally it'll be, so these are 3000 milliamp hour, generally it'll be a percentage of that. So 3000 milliamp hour capacity, I'll probably say charge at 300 milliamps. So a tenth of the capacity. And if you're leaving it overnight, you need to be aware that if you get it wrong, it could vent and catch fire or whatever. So it's better to be monitored. And if you do that, drop it right down as low as you can, really. So I'd probably, like I said, like I did originally, put it down to 100 milliamps and see what we get there. But anyway, so what I'll do to try and recover this one is bring it back down. Well, I'm going to leave it at 300 and 1.4 volt maximum, and then 300 milliamps going into it, and I'll leave it like that. Hopefully this will come back up. Then the proof of the pudding will be turning it off if I turn off the power supply, what I don't want to see is the voltage dropping like that. Now, obviously you charge these to 1.4, you can expect it to drop down to a similar level to these cells in here, so 1.2. But do that, reassemble it, and you may get your battery pack back. Okay, hope that was useful. Thanks, bye.